Hello, I'm sorry about this delay. We are starting now. There are only a few people left in the queue, I think. So it's a great pleasure to welcome you all to this conference on consciousness. This is the first in a series of large international conferences organized by the Human Brain Project in order to connect better with the rest of the scientific community. And consciousness was chosen as our first topic because it's, of course, highly relevant for brain research. And it remains one of the deepest unsolved questions in science with important implications, clinical applications, and ethical and technological implications as well. On the other hand, until recently, consciousness was quite a controversial topic. And those controversial ways could be regarded as a normal scientific problem to be addressed by normal scientific methods, or whether it should be better, was too elusive and should better be left to the philosophers still. So, therefore, I must admit that when 3 years ago I submitted this proposal to the Human Brain Project to introduce this as an explicit research topic, I was quite uncertain whether it would be accepted or not. So this is the proposal with Marcello Massimini, Stephen, Larissa and I, and with advisors Sean Hill, Giulio Tonone, and Christoph Koch. And I was therefore very pleased when this proposal was not only accepted, but this topic was also chosen as the first topic for these large international conferences. Thus, 1.5 years ago, Kathinka Evers, who is the leader of the Human Brain Project, asked me to organize this conference. And at that time, we already had organized a smaller conference or workshop in Paris on consciousness with Alain Destex, Kathinka Evers, Marcello Massimini, Cyriel Pennartz and I, and suggested to continue with this program committee, and also included Olivia Gossiers from Liège and Mavi Sanchez-Vives as our local organizer here in Barcelona. Now to the problem of consciousness itself. First of all, the term consciousness is used in many different ways. So before going on, let's try to clarify what we mean by this term here. Most researchers focus on the most basic concept, the primary phenomenological consciousness. Then being conscious simply means having subjective experiences of any type, percepts, thoughts, feelings, imagery, or dreams, which disappear in dreams of sleep or in general anesthesia or coma. And this is now a quite common definition by leading research in the field. But some prefer other terms like awareness, etc. And sometimes these semantic issues can lead to confusion. I'm sure this will be discussed here also, but whichever term we prefer, let's try to define clearly what we mean by them. As I said, until very recently, consciousness was largely seen as a philosophical topic and not widely accepted in mainstream neuroscience. And this seems rather a paradox, because our interest in the brain surely stems much from its unique ability to generate our experiences. And of course, a main reason for this paradox is the unique status of consciousness. Since the very concept is derived from our inner experiences, subjective experiences, it seems unlike anything else in science. It's all based on objective observations. So this doesn't seem to fit quite into the general framework of science. And this apparently unbridgeable gap was noted already by Leibniz and reformulated by David Chalmers as the hard problem of consciousness. But of course, science has been confronted with deep problems and apparent mysteries before, and has come up with novel and sometimes radical solutions. So it remains to be seen what kind of theory will be needed to successfully explain consciousness. Will we perhaps need a radical paradigm shift with new concepts, like Newton's radical theory of gravitation with action at a distance, or Einstein's principle of relativity and curved space, and the even more radical and spooky ideas of quantum mechanics, such as non-locality, wave-particle duality, and quantum indeterminism? Or is it sufficient to just go on patiently with our regular science as usual until perhaps the whole problem may kind of dissolve, much like the once mysterious problem of life kind of dissolved in the light of Darwin's ideas and molecular biology? Or maybe perhaps suffer from some inherent flaw or bias in our way of thinking about the whole problem. Is that the reason why the problem of consciousness seems so hard to us? I think only time will tell, but these so-called meta-problems of consciousness are very interesting, and they will be addressed by David Chalmers in this talk. And also I have a simple poster on this at this meeting. Of course, philosophers and thinkers have pondered this problem of consciousness for centuries, starting more than 2,000 years ago. And in addition to this rich tradition in philosophy, there have also been parallel developments in natural sciences, as illustrated very roughly and incompletely in this crude cartoon that includes only a few of the main contributors to this to this field, from biology, medicine, neuroscience, psychology, and so on. And of course, also information theory and computer science is becoming very important, here only represented by Alan Turing. Often there have been too little crosstalk between these different directions and disciplines, but now they meet more often, and this conference is an example of that. In the past centuries, great natural scientists such as Helmholtz, Huxley, Maxwell, William James, Sherrington, and Schrödinger will hide interest in the strange phenomenon of consciousness. But about a century ago, the behaviorist school in psychology claimed that introspection and subjectivity are unscientific, and they became very influential. So I remember very well, personally, from about 30 years ago, how consciousness was then regarded as a hopelessly elusive and even unscientific topic by most of my colleagues in neuroscience. But then, in the 1980s and 90s, the atmosphere gradually changed again, much because of pioneers such as Jean-Pierre Changeux, Francis Crick, J.L. Edelman, John Eccles, and Rudolf Linas. And they were soon joined by other younger pioneers, such as Christoph Koch, Stan Dahen, Giulio Tononi, Carl Friston, Anna Seth, and others. And of course, the clinical disciplines, neurology, anesthesiology, and neurosurgery have contributed a lot, as we'll also hear more about later at this meeting. And not to forget the many fundamental contributions from neurophysiology, cognitive neuroscience, and psychology. But again, this is only a very hasty, incomplete glimpse of some of the contributions to this active field. Since for this conference we mainly wanted to invite external speakers, we could only include a few talks from the Human Brain Project itself, whereas some excellent researchers such as Rainer Goebel, Matthew Larkham, and Lars Möckli and others are not speaking here. The new wave of consciousness research gained momentum about 1990 when Crick and Koch published several highly influential papers criticizing neuroscience for avoiding consciousness and arguing that the scientific attack on this problem should start now. So in 1999, John Taylor observed that atmosphere has changed enormously. Consciousness is now no longer regarded as a dirty word, and the time is becoming ripe for the problem to be solved. And in 2004, Crick declared that consciousness is now the major unsolved problem in biology, and Dahen and Changeux wrote that it's the ultimate challenge for this new millennium. During these decades, several theories of consciousness have been proposed. Two of the most influential ones are the global neuron workspace theory from Bars, Dahen, Changeux, and Nakash, which claims that consciousness depends on ignition of an extensive thalamocortical network that broadcasts information to large parts of the brain. And on the other hand, the integrated information theory, mainly developed by Giulio Tononi and supported by Koch and Massimini, Albantakis, Bolli, and others, which claims that consciousness depends on integration, differentiation of information in the brain, as we will soon hear more about. We'll soon hear more about these theories from Jean-Pierre and Larissa today, and also from Peter Rolsem and others tomorrow. But there are also several other less famous theories and ideas that deserve attention, as we'll hear more about from other speakers. These theories have inspired also novel methods for objectively assessing the capacity for consciousness in the brain. For example, the perturbational complexity index developed by Massimini with Tononi and others is been very promising with a lot of good results, and also the late P3B wave in the ventilated potentials that was introduced by Johan and Changeux. We'll hear more about in Marcello's and Jean-Pierre's talk. Another highly influential concept is the neural correlates of consciousness, which was first proposed by Crick and Koch in 1998 and defined as the minimal set of neural events sufficient for a specific conscious percept. So stimuli from the outside world evoke a variety of neural processes in the brain, only some of which are thought to be immediately giving rise to our conscious percepts. And these are called the neural correlates of consciousness, the subset of events. And since then, the concept has further evolved. And last year, Christoph and colleagues published this paper where they proposed two varieties: the content-specific NCC, which determines a particular component within an experience, such as a face or a color, and the full NCC as the neural subset supporting conscious experiences in their entirety. So, while consciousness has for centuries been a central theme in philosophy, it is now at last also becoming a central theme in neuroscience. And it is not only of academic interest, but it also is highly relevant for several branches of clinical medicine and technology, with important implications for ethics and society, ranging from neurology to anesthesiology and robotics. And the Human Brain Project seems eminently suited for addressing this cross-disciplinary challenge, because it brings together expertise ranging from experimental and theoretical neuroscience to brain simulation, neuromorphic computing, and robotics, as well as ethics. And the Human Brain Project also has this multi-level experimental and computational approach from molecules, synapses, and neurons via circuits and systems all the way up to behavior and mental phenomena. And the HBP also has a particular strength within computational neuroscience, including two unique neuromorphic computer platforms, the large analog machine, BrainScales, and the massively parallel Spinnaker machine with more than 500,000 cores. Of course, computation modeling is essential for detailed mechanistic understanding of any highly complex system, including the brain. And just to illustrate briefly, with one example that I know fairly well, how this may be relevant for consciousness research, consider these two dimensions of consciousness. We have the level of consciousness, that is wakefulness and arousal, and the content of consciousness, and the arousal level is determined mainly from the brainstem and basal forebrain, we believe, whereas the content of consciousness represents detailed information processing in the thalamocortical system. So in the Hill-Tononi model, which we'll hear more about from Jean tomorrow, simulates the thalamocortical system, very simplified, of course, with a couple of visual cortical areas connected to a thalamus that is being modulated so it can undergo transition between wakefulness and sleep, which then represents the different levels of consciousness. Whereas the content can be represented by these stripes that represent the detailed information process in the cortex. In collaboration with the Massimini and Plesser groups and Jean, we are now implementing this model in the NEST simulator, which is an important simulation tool within the Human Brain Project, and we'll use it to study how different measures of brain connectivity, integration, and differentiation changes with the level of consciousness. And complementary efforts are being done in other groups in the Human Brain Project, including Mavi Sanchez-Vives group here in Barcelona. Now the Spinnaker team of Steve Ferbs in Manchester is implementing our model into their massively parallel neuromorphic computer, Spinnaker, for more extensive and realistic simulations. But these models so far use only point neurons, and therefore they still lack important subcellular mechanisms that may be essential. In particular, so-called apical amplification by context information arriving at the distal dendrites. That was discovered by Matthew Larkham several years ago, may be essential for conscious perception, as shown by this recent science paper with experiments in mice. Therefore, we plan to implement a multiple compartment neurons also in our Hill-Tononi model, and the brain scales team already did this in their analog computer. This is just to illustrate how the multi-level approach in the Human Brain Project may be relevant for conscious research, and I'm sure we will hear much more about this in talks to come. Within the Human Brain Project, multi-level integration of experimental and computational approaches take place not only across the groups and the sub-projects, but also within each of them. So an example is the conscious brain work package that I'm leading, where we use both experiments in humans and animals, as well as computer simulations, as we'll soon hear much more about from Marcello, Olivia, and Cyriel. In a recent review of the Human Brain Project that took place in Stockholm a few weeks ago, we were asked by the reviewers what is special about the conscious research within the Human Brain Project as opposed to all the other good work going on in this area in the world. And I think an answer is that the Human Brain Project, which is does not belong to any particular group or camp that tries to promote one particular model or theory or method, we can play a quite unique role by testing in parallel in a kind of impartial and neutral manner different and competing theories and methods of consciousness. Thus, the HBP teams can test them side by side under nearly identical conditions, thus enabling a fairly fair comparison. And this is from our proposal in 2015, where we want to directly compare novel and established EEG-based methods and also test leading theories of neural subset of consciousness, global workspace, and integrated information theory. Lastly, I will just very briefly mention that we already had some outreach events, one at the Society for Neuroscience meeting in Washington last November, which was very well attended by more than 1,000 people, and this workshop in Paris, both on consciousness and feed forward and feedback and processing and brain states. And in Oslo, we had for the last 5 years this Forum for Conscious Research with many excellent speakers, including David Chalmers, Stan Dahen, Giulio Tononi, and many others. But now to today's program. So we have 4 main sessions. The first one today is on the fundamental aspects, including theories of consciousness. Then, in the afternoon, neurobiological mechanisms and correlates of consciousness. And tomorrow, models, simulations, and emulation of consciousness. And lastly, clinical, and ethical, and societal implications of consciousness research. And each session is chaired by 2 HBP members from our program committee. One of them will give an introductory talk, while the following speakers is a mixture of our eminent external lecturers and a few special selected speakers from the Human Brain Project. And after the first session today, Marcello Massimini is scheduled to give a special lecture with an overview of the ongoing consciousness research within the Human Brain Project, much more thorough than I've been able to do now. Unfortunately, he called me the day before yesterday and told he had become acutely ill, so he's not able to travel, but heroically he will give his talk remotely. He's recovered a bit now today via Skype, so we look forward to that. And in addition, we also have flash talks by a young researcher and poster sessions and a robotics demonstration by Daniel Camilleri from Sheffield. And tomorrow afternoon, we also have a roundtable discussion. And tomorrow evening, a public lecture by Stephen Lores where I also give a brief introduction. So that was my introduction, and now we go directly to the first session that is now chaired by Kathinka and I, where we have 5 talks, 3 of which are by our eminent invited speakers, David Chalmers, Ned Block, and Larissa Albantakis. But Kathinka will start, and we'll end the session with the talk by Jean-Pierre Changeux. So our first speaker is Kathinka Evers, who is a member of the program committee and one of the very few professional philosophers within the Human Brain Project, where she is leading the Ethics and Society sub-project that focuses on social sciences and humanities. Kathinka is a professor of philosophy at Uppsala University in Sweden, where she leads a research team working on philosophy and neuroethics. She has been working at many universities throughout the world, as a research fellow at Oxford University and at the University of Tasmania, and has been invited professor at the College of France, and has held a chair at the École Normale Supérieure in Paris. She is also an honorary professor at the Universidad Central de Chile in Santiago. And she's also an enthusiastic high-altitude mountain climber, so she is used to navigating in uncertain and terrain and lofty conditions. So I welcome you to talk, Kathinka.
Well, thank you, Johan, for this nice presentation. Yes, as Johan started by saying, as we all know, consciousness was a rather late arrival in the scientific arena. And in addition to the scientific rejection, which is no longer a major issue, there are 2 other obstacles that are more rarely mentioned, but which I want to mention now because they are more relevant for what I'm about to say. One concerns the fact that the mind sciences have primarily used natural languages to develop their theories and present them, and this has been a major obstacle for thought. We see a sharp contrast here to physics that use primarily mathematics in their theories, and when they in popular communication, when they use natural languages, the theories often have a deeply counterintuitive allure and use terms that in a quite different way from how they are used in everyday practice. For example, matter, space, time. And this is accepted. Now, we have seen wonderful scientific revolutions in physics from Newton, Einstein, Bohr, and onwards, and I don't think that we would have seen them if physics had been pursued in everyday language. Now, we are, of course, eagerly awaiting some similar scientific revolution in the consciousness research, but I think that in order to see that, we need some linguistic innovations, either by coining new terms or by allowing old terms to have a rather different meaning from what we are accustomed to. Now, this is not a new concern. The philosopher Searle, he often complained about how, for example, natural languages are permeated with dualism, making monistic positions rather difficult to even express. And that is an obstacle for thought, because language influences our thoughts and our intuitions. Now, another obstacle was the rather simplistic views that especially those who rejected consciousness from scientific studies had of the brain, insofar as they even looked at it. Many regarded the brain as a sort of input-output machine, receiving impressions from the external world that it then transformed to output representations. But this is now outdated. Around the 1980s, somewhat earlier even, new dynamic theories and models of the brain emerged. And it's interesting to see that at that time, consciousness reappeared on the scientific stage. Crucially, these new models depicted the brain as intrinsically active and emphasized the resting state activities which increase in the absence of external input. They also emphasized value as a fundamental characteristic of the brain, that has a mode of operations which is evaluative and selective. And these models can be taken to suggest how consciousness is even possible, thus with relevance to what David Chalmers called the hard problem of explaining how or why we have phenomenal experience. Now, we can read, for example, in Jean-Pierre Changeux' now classic work, Neuronal Man, that the brain is intrinsically and autonomously active. Even in the absence of external signals, it develops spontaneous representations and evaluates them, striving to build meaningful models of the world in what can be described as its projective style. But without any values, a system can neither learn nor remember. It has to prefer some stimulus to others in order to learn. And this classical idea in learning theory was expressed in neuronal terms by notably Edelman, Changeux, Dehaene, and later in models of predictive coding developed by notably Andy Clark and Carl Friston. Some years ago, during my lectures at Collège de France, I suggested that precisely these features could be taken to be the evolutionary hallmark of consciousness, which is a figurative way of saying that the former signify the latter. So that preferences, the capacity to evaluate, is what distinguishes merely active matter from active conscious matter. We are speaking of different types of change in these systems. So the idea being that through evolutions, brain have developed that are intrinsically, spontaneously active with a mode of operation that is selective, evaluative, projective, and predictive. And what I and my colleagues are suggesting is that we might describe the brain as conscious by virtue of these characteristics, and consciousness as a multi-layered fundamental characteristic of the brain as it has developed through evolution, provided that necessary conditions are fulfilled. For example, that the brain retains appropriate intrinsic and resting state activity. And we are talking here both of what Ned Block in 1995 coined as access consciousness, or the brain's information processing, and phenomenal consciousness, the feeling of what it is like to be X, to use Nagel's expression. Now, it could conceivably have been otherwise. Evolution is a question of fact, not logical necessity. So the relation between the world and the brain is contingent, whereas the proposal of identifying consciousness in terms of the brain's intrinsic and spontaneous and projective activities is a conceptual relation. And I owe this figure to discussions with Georg Northoff, who is publishing now a very important work on the world-brain relationship with MIT Press. And for those who don't know, Georg Northoff also has a very interesting theory of consciousness called the temporospatial theory. Now, the vast majority of the brain's selective operations are unaware. As Joseph Ledoux once put it, awareness is just a very small tip of a mental iceberg. And there is a very strong tradition in notably Western psychology, dating from Freud, Janet, Jung, James, and onwards, to separate the human psyche into two distinct realms, unconsciousness and consciousness, and to identify consciousness with a little tip that we call awareness. And most people, especially perhaps in Occidental cultures, have learned to think in this way. But is it realistic? And in order to answer that question, we need to look at what distinguishes the unconscious from the conscious. In Stanislas Dehaene's latest book, we can read that consciously aware or unaware, the brain correlates and selects information, associates meanings, rapidly performs computations, sophisticated mathematical operations, complex inferences, perceives the effective value of stimuli, and influences motivation, value judgment, and goal-directed behavior. And in a new school of thought in cognitive science and neuropsychology called the new unconscious, new here denoting that the unconscious is not understood as a Freudian unconscious, which is rather emotionally laden, but as a matter of how the brain codes information. The unconscious is able to perform every fundamental high-level cognitive function performed by consciousness. For example, cognitive control, pursuit of goals, information broadcasting, and reasoning. And this has led one of the proponents to conclude that introspectively inaccessible mental processes may still be conscious. They may be phenomenally experienced in a manner or in an area of the psyche that escapes egoic introspection. The notion of an unconscious, argues Kastrup, may at root be a linguistic inaccuracy originating from mere operational convenience. So, the narrow concept of consciousness as awareness and the traditional sharp dichotomy between the conscious and the unconscious stands challenged by these empirical studies emphasizing the complexity of the unconscious. And here I wish to draw attention to the fact that this is not merely a semantic issue. How we use words can have very important ethical repercussions. One of the areas where this is most relevant concerns the clinical context of patients who suffer from different disorders of consciousness. Modern technology has offered us possibilities to assess residual consciousness in these patients who have been correctly diagnosed by traditional behavioral diagnostic criteria. What we have seen also is that consciousness is far more complex than hitherto imagined, that on very deep layers of the brain's activities, there are activities that suggest the possibility of experiencing pleasure or pain that traditional diagnostic criteria and methods would not be able to detect. I'm not going to go into the details here because we have a whole session devoted to that tomorrow. Some of the most prominent researchers in the world in this conference, notably Melanie Bolli, Stephen Loris, Olivia Gossery, Marcello Massimini. So I will not go into the details, but I want to focus on the point that clinical practice does often not follow suit, especially in Sweden, or at least in Sweden. When a person has been diagnosed with, for example, unresponsive wakefulness state, they are not in any way given additional therapeutic treatments. They are well treated in the sense that they are put in a comfortable home, they are put on life-sustaining measures, but nothing else is done. So in ignorance of the complexity of the unconscious, the possibility of suffering or nociception, or the possibility of pleasure, music, tactile pleasure, the hearing of a loved one's voice, is not even taken into account because they assume that if there is no awareness, there is nobody home. So this is not mean. It's not, and it may be a bit a question of priorities in healthcare, but it's a question of ignorance and a very strong focus on awareness. Now, the unconscious is in many ways ethically relevant, as we have been trying to show in various articles, and there are different types of arguments for this. The cautious argument would argue that if consciousness is ethically relevant and the unconscious is at least in part the result of consciousness or plays an important role in shaping consciousness, then the unconscious is also ethically relevant. They are not causally disconnected. A stronger argument would say that if consciousness is ethically relevant because of what it can enable, and the unconscious can enable similar things or the same things, then the unconscious is also ethically relevant. Now, against this background, we introduced last year a model of consciousness which is more expansive than the traditional ones. We here is Michele Farisco from Uppsala University, who also has a poster in this conference, Stephen Loris from the University of Liège, who will speak tomorrow, give the popular lecture, and myself. Our suggestion is that we conceive consciousness in terms of the brain's intrinsic and resting state activity and the brain's disposition to evaluate and model the world, and that we leave the sharp dichotomy between the unconscious and consciousness behind and rather view consciousness as a continuum, where on the one side of the continuum we have awareness, cognitive or non-cognitive, and on the other side we have lack of awareness, also cognitive or non-cognitive. So we would argue that we have phenomenality throughout the continuum and the possibility of some subjective experience, even without awareness. We also have personality on different levels here. What we do not have is meta-consciousness or self-reflection. That we do not have along the whole continuum. So in this model, consciousness becomes very closely connected to life. You can only lose it, the brain can only totally lose consciousness by dying. So in a manner of speaking, cogito ergo sum is reversed into sum ergo cogito. I am, therefore I think. And I was particularly interested to see, when I saw the list of talks, that Carl Friston has that as the title of his talk. If I was interested before, I'm even more interested now. Of course, we also address the issue that for many people to say that consciousness can be unaware is an oxymoron. Indeed it is. It depends on the definition and linguistic habit. What we are proposing is a different definition and a different linguistic habit, where consciousness is conceived as a broader concept than mere awareness. I hasten to point out that the ICT is not a theory in the sense of an empirical scientific theory that can be subjected to experimental testing. It is a proposed conceptual theoretical framework inspired by and compatible with empirical science and developed with a view to empirical applications. It is not directly inferred from empirical hypotheses. It is compatible with different empirical theories that strive to explain how consciousness works. I think it's compatible with both the integrated information theory and the global neuronal workspace theory. So the ICT is not open for direct falsification or corroboration. It's a question of plausibility and inference to the best explanation. So we face some challenges. First of all, we have been speaking about the appropriate intrinsic activity. Now that remains to be specified, and that is not a purely philosophical question or a conceptual question, it's very largely an empirical one. We also have the interesting question of panpsychism, or what in our model would be called biopsychism, because we have contextually limited our discussions to biological reality, notably brains. We have not expressed ourselves about the possibility of there being consciousness in non-biological or non-organic entities. But referring back to what Edelman argued in his classical critique of functionalism, the nature of the hardware determines the nature of the software. So the nature of the matter that is conscious would influence the nature of the consciousness it may possess. So in my view, if there is such a thing as a non-organic conscious entity, there is no reason at all to think that its consciousness would be in any way similar to ours. And that poses an epistemological challenge for testing it. Because if there is not one configuration between matter and consciousness, there cannot be one single test either. So that is a big epistemological conceptual challenge. Now, if we want to avoid biopsychism, we need further limiting conditions. For example, which was suggested to me by Wolf Singer in discussion, generative functions connected to cortical structures with recurrency as wiring principles, which would thus exclude invertebrates and insects. Again, it's a bit of a question of definition. Secondly, we have begun analyzing how the different layers of consciousness interact in the aim of understanding the growing epidemic of opioid addiction, which is plaguing not least the United States, but increasingly also in Europe. That is research that we are doing together with Jean-Pierre Changeux. But now for the positive arguments, what do we gain by ICT? I mean, if someone says, I really prefer to identify consciousness with awareness, we can't simply tell them that, I reckon that your comfort zone is way too narrow. We have to have positive arguments. And I have 5, actually. One is that it's conceptually simple. We are not introducing different realities in mind science, where consciousness and unconsciousness stands as a dichotomy inside the mind. We have one reality, the conscious brain. It's a monistic model, and I'm very strongly in favor of monism. It's also empirically realistic because it acknowledges the greater complexity of consciousness, and in that sense of the unconscious, which is a term that we keep in the ICT, but we keep it as an adjective that is synonym to unaware, not as a noun. It's also ethically sound because it suggests a more appropriate management of patients with disorders of consciousness and acknowledges that they can be in a subjective state even without awareness and thus merit therapeutic measures to be put in place. And it's, I think, an aid in understanding addiction. It's also self-empowering. If you do if I may call it a gestalt switch of conceiving the brain as intrinsically, fundamentally conscious, also on deeper levels of consciousness without awareness, you can learn how to connect to these levels. This is something that has been very interestingly described by pilots, young war pilots in the Second World War, how when faced with extreme danger, and it's something that all high-risk sport activists will recognize, I think, you cannot only use the awareness because it's fully occupied by being afraid. You do not want to only use unconsciousness because that is too below the surface. So you need to connect to the intermediate levels. And I do think that if psychologically you get used to the idea of conceiving your brain and yourself as fundamentally and deeply conscious, not only in that little attention span of here and now, that facilitates the connection to the deeper layers. It can even save your life. Finally, I want to come back to the first question, why has consciousness evolved, as David Chalmers asks? Well, I think that connecting consciousness to evaluation suggests a part of the answer, namely that it intensifies intentionality, what Spinoza and others before him called conatus, the innate inclination to being and enhancement. And I think this question is of strong relevance when we try to compare artificial intelligence with human intelligence, because a question that is extremely interesting is what, if anything, does consciousness bestow upon human intelligence that makes it uniquely capable in comparison to artificial intelligence, which we presently assume to be non-conscious? The question is, of course, especially relevant when artificial intelligence in some countries threatens to replace human beings to 65% of its working force. But that question would take me far too long to address, and I will not go into that now, so this will be my last slide. I will let Spinoza have the last word, and just thank the audience again, this time for having listened. Thank you very much.
And now time for a few questions to address to Kathinka's talk before the general discussion. Yeah. Ned.
So you linked consciousness with value, and so I wondered, and you also seem to make a connection between that and learning. But I wonder what you think about the apparent existence of unconscious learning.
I think it's a very important part of learning, and I think that the unconscious learning would also be, first of all, most of the learning would probably be unconscious if you speak about the brain, because referring back to Jean-Pierre Changeux' theory of knowledge acquisition, which I think I adhere to, the brain produces masses of pre-representations that it proceeds to test against the external world in which it operates, and also against previously established representations, discarding those that do not fit and establishing and stabilizing those that do fit. So, as Jean-Pierre said, to learn is to eliminate. The vast majority are eliminated. And most of this process is done without awareness. And that is very important. I don't think we could survive if we didn't function in this way.
Kathinka, some of the psychologists like Gigerenzer or Kahneman, they would maintain that conscious deliberation, conscious problem solving follows different laws than subconscious problem solving. The former being rational, serial, could also be taken on by a computer. If you have reliable variables, that will give a reliable result. The latter being able to consider at the same time very many underdetermined variables and find a quick heuristic solution. And they maintain this dichotomy between the conscious reasoning and the subconscious processing on the basis of heuristics. Would you maintain this distinction, or would you say it's just a continuum?
I would maintain it in a different sense. I would certainly agree that the different levels function differently, and I think one of the really most interesting issues for consciousness research is to really analyze how consciousness works on the different levels. I think it's more complex than hitherto imagined. What I do not agree with is a sharp dichotomy between the unconscious on one side and the conscious on the other, in part because I think it makes one focus too much on awareness. And I don't think awareness is the most interesting feature to analyze when we are speaking about consciousness. Also, I don't necessarily agree with the description of one being more rational than the other. I think both can be extremely logical, extremely rational. And mathematics can, for example, be performed on different levels, as many have vouched. So I would keep the distinctions in many sections, but not as a sort of ontological dualism. Does that reply? Yeah.
Thank you very much for this very elegant presentation. I have a problem in the slide where you refer to Wolf-Singer and the fact that there are no recurrent kind of connection in insects, and therefore that the definition that we currently have does not apply. And I may say that in my last slide I showed that insects may have some rudiments of consciousness, and whether or not there are some kind of self-reference, this is a good question to solve at this stage. Now, so I think this was just put as an example, and we can discuss with Wolf whether this is what he thinks or not, whatever. The last thing is that when you are talking about ethics, do you really believe, and we discussed that, but do you really believe that one can have non-conscious ethical deliberations?
Well, starting with the first question, I drew attention to the challenge of the question of biopsychism. I didn't assert, I didn't mean to assert that invertebrates or insects could not have consciousness. It's possible that we should acknowledge that there is some form of consciousness in bees. I think that is very largely a zoological and a neuroscientific question coupled with conceptual analysis. I don't want to discard that possibility, especially since bees have a very interesting cloud intelligence, which I find interesting to compare to human intelligence. Could we possibly develop cloud intelligence? It seems that the human intelligence is very individualistic, unlike the bee intelligence. But that's a huge issue. I think it's enormously important, and I look forward very much to your last slide and your discussions with Wolf. As for your second question, yes, I think you can have very important, at least moral deliberation. I'm not sure about ethics. I have a problem with the term ethics here, because ethics seems to me to be a sort of par excellence an aware activity, whereas what feeds into this aware activity are moral emotions. But how deeply it goes, I'm not sure. Maybe one can have it. I wouldn't exclude it. But that is not part, so far as I can see, of the studies that have been made. But it is an interesting study. Difficult to test. But I would not exclude that we could have, if we have sophisticated mathematical calculations that are unconscious, why could we not have sophisticated ethical deliberations that are unconscious? It seems to make sense.
Okay.
You mentioned this sort of intermediate stage of experience or consciousness. Yeah, it's not consciousness, it's between the conscious, unconscious, you said. Would you describe this as, let's say, we cannot access this as such an experience or consciousness, but it's still there? Would you describe this as pre-phenomenal? Would it have the phenomenal features or pre-intentionality or pre-qualia or pre-phenomenal? And would you second consider, because as a psychiatrist, I would say that this level of experience, and you see, I use the general term of experience as a broad term covering both your unconscious, conscious here. Would you consider, let's say, psychiatric disorders like schizophrenia or depression, where this, let's say, pre-phenomenal level of experience breaks away? Would you consider that as a support, empirical support?
I would not call schizophrenia, the experiences of schizophrenia, pre-phenomenal. I would call it very phenomenal. It's profound.
It breaks away in schizophrenia.
Yes.
That level breaks away, and that's why the phenomenal or cognitive level is so much emphasized.
It's an interesting suggestion. We haven't gone into that area, but it is an interesting suggestion. I would not discard it, but basically the core idea of this continuum is that you have a non-zero level of consciousness throughout the brain's intrinsic and resting state activities on the appropriate level. So the question or not whether someone has schizophrenia or depression, even being dreaming, they would still be in a phenomenal state.
Thank you very much. I think we have to cut the discussion there.
Okay, I have the last question.
More speaker, will be time for more questions afterwards, but I think you go on with Ned Block talks. So,
Can't I ask a question? We asked me from the beginning.
I think time is up, so we got plenty of time afterwards, okay? Okay, so our next speaker will be Ned Block, and he hardly needs any introduction, of course, as one of the leading philosophers of mind today. And he's the leader of the Center of Mind and Mind, Brain and Consciousness in New York University, together with David Chalmers, and he's also the professor of philosophy and psychology since 1996. And he's, of course, famous for his criticism of functionalism and for his highly influential distinction between phenomenological consciousness and access consciousness, which is becoming more and more relevant for the hotly debated issues in neuroscience today. So, and with this, lively debate with Dennett is, of course, interesting in that context. So I met Ned first time in Oslo many years ago. He probably doesn't remember that. He was invited to speak. And then again, several times in New York at David Chalmers' apartment at parties there. And I always appreciate his sharp arguments. So I'm looking very much forward to your talk, and quite curious too. So the title is Conscious and the Joint in Nature Between Cognition and Perception. See the time over there, okay? Yeah.
Okay, can you hear this? All right. The idea of this talk is to talk about the importance for thinking about consciousness of the distinction between perception and cognition. So this little barbed wire fence is meant to indicate that I think there's a difference of kind between perception and cognition. I think this is relevant to theories of consciousness because it excludes cognitive theories of consciousness. So just by what I mean by cognition is thought, reasoning, problem solving, and the like. The idea here is that no state is both a perception and a cognition, but you can use perceptual simulations in cognition. The conclusion I'm going to be arguing for is that conscious perception need not involve cognition or conceptualized states, so cognitive and conceptual theories of consciousness are wrong. So the border between perception and cognition that I see depends on the idea that perceptual states are iconic in format, non-conceptual and non-propositional in content. I'll explain those terms in a minute. I think that there's some truth to the modularity idea, which I'm not going to have time to go into, although I think there can be a lot of top-down effects on perception, and the perceptual constancies, which I'm also not going to go into. So another aspect of terminology is the use of the word concept. So the term concept is ambiguous between a sense in which it means something like meaning and a representational sense. It's the representational sense that I have in mind. And importantly, a concept is a representation that embodies a way of thinking. So Oedipus had two different concepts of Jocasta, the concept you might put as mom and the concept you might put as wife. All right, so those are terminological points. Now, let me just give an illustrative example of what might be a pure case of perception without cognition or consciousness. And that involves the wasp. I'm not talking generally about insects, but specifically about the wasp. And I rely on some work by the philosopher Peter Godfrey Smith. And he makes the following points about the wasp. First of all, they have great vision, including many perceptual constancies that we also have, like size constancy, shape constancy, etc. In addition, there's a strong evolutionary pressure for them to reduce the size of their nervous system. He thinks there may have been an earlier pre-wasp ancestor that had some rudimentary cognition, but what we've got now is a creature that has a number of interesting properties that suggest that it doesn't have either consciousness or cognition. The main property that suggests no consciousness is there's no wound tending. Now, many animals, if they damage a leg or a part of them, they will favor that part, but not the wasp. What he says is the wasp, you can cut off bits of it and it continues doing what it was doing before without taking into account at all the damage to that part, making it a really good case for a zombie. And so that's the conscious part. The cognitive part is, first of all, they have a very short lifespan, so they have little use for learning. And here's the most interesting thing. They've been shown capable of Pavlovian conditioning, but not instrumental conditioning where a voluntary response is negatively or positively reinforced. And then a final property is they have stereotyped action patterns. So this is a famous passage that many people know about. I won't read you the whole thing, but basically the wasp has a certain stereotype procedures, and they will repeat those procedures over and over and over again. Wooldridge mentions one case of 40 repetitions, not taking into account changes that have happened. So they're extremely inflexible. So anyway, that makes the case that the right point in this diagram for the wasp is in this perception that excluding consciousness and cognition. So just to get the idea out there that these things are different from one another and there can be perception that has neither consciousness or cognition involved in it. So let me motivate the kind of issue I'm talking about by talking about the use of the word looks. So we describe something as looking blue, looking like a lot of dots, looking like a face, looking expensive, looking like a piano. But which of these looks are genuinely perceptual as opposed to a matter of perceptual judgment? Whereby perceptual judgment, I mean a cognitive state in which you have a thought-like state to the effect that something is in the world or that you're perceiving something. So one issue is what's the difference, and another issue is how could we tell? So in the case of blue, that's a low-level perceptual, and there's a small finite class that are products of sensory transduction that are causally involved in the production of other visual representations. The perceptual representation of a face or of numerosity is high level, not the low-level transduction ideas. So I can illustrate some of these ideas with a famous experiment, which everybody knows about, but probably a few people have experienced, and you're about to experience it. Okay, now many of you will have seen a 6. What was the suit of that 6? Come on, somebody say something. Hearts, diamonds, any others? Okay, so here's what it was. You've now been a subject in a truncated version of the Brunner-Postman experiment of 1949. So many people say that they had the experience of a 6 of hearts. What you actually saw on the screen was a red 6 of spades, okay? And then that raises the question of whether that 6 of hearts idea that you had was a perceptual experience or a post-perceptual judgment involving a conceptual overlay on perceptual experience. So the point made by this example is that when you report a perception, there is a real issue as to whether you genuinely have a pipeline to the actual conscious perception, or whether what you're reporting is a cognitive state that was imposed on that perception. And so I would suggest that that is true of what it is for something to look expensive or to look like a piano. I doubt that those are really perceptual states. So here is the table of contents for the rest of the talk. I'm going to talk about basic perceptual phenomena just to give you an idea of how you might investigate this. So I need you to look at that red dot, okay? So keep your eyes on that red dot or you will not experience what is about to happen. Okay, so I'm going to show you another slide. Keep looking at the red dot. I'm going to talk while you're looking at the red dot. So I'm going to show you another slide, and I need you to, the audience must say the word left, meaning more on the left, or the word right, meaning more on the right. And you have to say it immediately. Don't wait. As soon as I say go, keep your eye on that red dot, keep your eye on that red dot. As soon as I say go, you have to say the word left for more on the left or right for more on the right. Okay, are you ready? Just shout it out. 1, 2, 3, go. Okay, now look more closely. Okay, those are exactly the same. All right, so what happened here? I mean, every dot on one side is the same as the dot on the other side. So you have perceptual channels for numerosity. Your perceptual channels on the left were, as the people say wrongly, but I'll say it, fatigued. The low numerosity channels were fatigued. And so when you saw these two identical things, there was a preponderance of low firing channels on the left and high on the right. And the reason I'm showing you this is just to give you an idea of how you can investigate perceptual phenomena. One of the ways you can investigate it is using perceptual adaptation. Now, in a longer version of this talk, I have a whole bunch of other perceptual phenomena, but I will skip all those and go into the point that perception is constitutively, that is of its nature, non-propositional. Okay, so what shows it's non-propositional? One cannot see something as if red then blue. Propositional representations allow for logical relations. If P is a proposition and Q is a proposition, you can formulate the proposition, if P then Q. But you can't do that with perception. One can see something as non-blue by seeing it as red, but one cannot see something simply as not blue. It doesn't admit of negation. One can see something as intermediate or indeterminate between red and blue, like, say, purple, but not as having the disjunctive property of simply being red or simply being blue. And the same with other logical machinery. It appears that perception does not allow for that logical machinery. Again, in a longer version, I do more on this, but now let me go to non-conceptuality. All right, so philosophers have talked about two different notions of non-conceptual content, the way something is represented to be, or non-conceptual state. Non-conceptual content is a kind of content that cannot be a content of a paradigm cognitive state, such as a belief or thought. A state is non-conceptual if the subject of the state need not have the concepts required to characterize the state's content from the subject's point of view. So I'm going to be talking about non-conceptual content, but my point would be equally work with non-conceptual states, and I really think these amount to the same thing, but I don't have time to go into it. Okay, so I've already mentioned one example of something that might be non-conceptual. This wasn't really serious, it's more anecdotal, but and that is the WASP case. But I have another case where there is actually some serious evidence, and that is the case of infant color perception. So first of all, we have categorical perception of color. The band of wavelengths in a rainbow is continuous, but you see the colors as digitized. the signature of categorical perception is that you're faster and more accurate in discriminating between categories than you are within categories. And interestingly, infants show categorical perception of color before they have conceptual abilities. And that's the main point that I'm using this for. Infants have categorical perception before they have conceptual abilities involving color. So I'm using the work of Anna Franklin, and she's done fantastic work on infant color perception. So one technique she uses is you show the infant a uniform screen with a disk of a different color. And the infant will tend to saccade to that disk if the infant sees it as a different color. They saccade more quickly if the disk and the background are from different color categories, and you can use this to gauge what their color categories are. And you can do this on adults as well. What she finds is that 4 to 6 month old infants have almost adult levels of color perception. Another technique that is used to indicate the color categories is a habituation technique. This is not the same as adaptation. The idea is that you show the child one on the left, one on the right, the same color, same color, same color, and then when there's a different color, the child's interest comes back, so which is gauged by whether the child is actually looking at the screen or looking at something else like its foot. You can use this to gauge whether they see these two as different colors, and again, as with the previous technique, whether they see them as different color categories. And here's the basic slide from her work, the data slide. And these lines represent the same category. Double lines is really the same category. And what you see is certain gaps where the babies have, those are gaps between different color categories. Here's another display. This is the infant. This is a gap. This is a gap. This is a gap. So there are 4 gaps. And these are data from 4 different language groups. So this is English, and the stars represent cases where our category boundaries overlap with the baby's categories. So babies see this sort of distinction between, I don't know, kind of brownish green and greenish brown as a color boundary, but in English we don't make that distinction. So here is the interesting point about this, which is that it looks like infants' color categories are not just immature versions of adult color categories. So this is within category discrimination, and this is between category, and this is initiation time. And as you can see from this graph, infants have categorical perception on the left, but not on the right. So this stripy one being faster than the solid one is the indication of categorical perception. In adults, it's stronger on the right. And the suggestion here is that for infant color categorization and color perception is basically a right hemisphere phenomenon. In adults, it's largely a left hemisphere phenomenon. When we get language, we impose our linguistic categories. So the important point is this is evidence that for babies, color perception is language independent. So here are some further arguments for this, but I'm going to just to focus you on the idea here is that I'm talking about this period. 4 to 6 months, they have almost adult level color perception. By 12 months, they're starting to get color concepts. It's this in-between point, maybe 6 to 11 months, where the infants appear to have color perception without any color concepts or the concept of color. So that's non-conceptual perception. So let me skip a little bit because I'm running. So here's the basic evidence. So this is one form of experiment. So you have a baby looking at a screen, and you have one color of something go out from one side, another color from the other side, and then when the screen goes down, even at 12 months, if the infant does not expect two things, okay, suggesting that that color difference did not register conceptually. And this is a striking phenomenon. They can do this for shape and kind, but not for color. So just color experience can be non-conceptual. There's another kind of experiment, a similar type of idea. You have one thing come out from a screen, another thing come out from the screen, and then the question is whether you've got those two things when the screen goes up. And 12 months old is surprised by a change in shape, but not in color. Here is another form. Can they learn the rule? If two things are of the same shape, there will be an interesting event on the left. And the answer is the 12 months old can learn that, but they can't learn the same idea for same color. So a further point is that on the average, children know 4 basic color words by 3 years, 3 months. And Mabel Rice did a teaching experiment in 1980 in which she took a group of 2 to 3-year-olds who knew no color words and taught them the difference between red and green. It took over 1,000 trials. And many people, including Charles Darwin, I won't read this, have thought that their children were colorblind because they were so bad at learning color words. Because you have kids who know a lot of words for many different things. They don't know their color words. It used to be in the turn of the 20th century that this took until, the 4 basic color words took until 7 years. But now it's, or at least in 1980, it was down to 3 years, 3 months, and it might be earlier even so now. Anyway, here's the summary. Infants can see colors at near adult levels at 4 to 6 months, and they also perceptually categorize them. They can use shape, size, and kind information in forming expectations and as inputs to rules at least 6 months earlier than they can use color information. 2 years later, most children do not know the basic color words, and many children don't seem to know what adults are talking about when they talk about color. And substantial reasoning with color seems to happen at the same time as learning color words. This suggests that 4 to 6 month olds have color perception without color concepts. And that suggests that there is some real possibility that all perception is non-conceptual. And that suggests, I mean, it doesn't prove that, of course, because it's just one case. But so here is the distinction, the account I mentioned before of iconic, non-conceptual, non-propositional, and a few other things. Now let me move quickly, because I'm running out of time, to what's wrong with cognitive and conceptualist theories of consciousness. Okay, so since perception, and in the case of the children, it's conscious perception, need not involve any concepts or any cognition, it does seem to follow that cognitive theories of consciousness are wrong. So here is the most well-known example of a cognitive theory of consciousness. It's the so-called higher order thought theory, or HOT theory. The idea is that what it is to have a conscious pain is to have a thought to the effect that one has a pain. So what makes the pain conscious is there's another state, and it's a cognitive state, which requires a concept of the conscious state. So if that HOT theory is right,